let's dive into a core concept in object-oriented programming, method overriding. It's one of those ideas that, once it clicks, totally changes how you think about building flexible and powerful software. In this explainer, we're going to break down exactly how it works and how a child class can totally redefine the behavior it inherits. So think about this for a second. What if a child class could inherit some functionality, but then completely change how that functionality works, all without touching the original name? You get a method, but you don't want the default behavior. So how do you modify it safely? Well, that's the exact puzzle we're solving today. At its heart, the whole idea is actually pretty simple. A subclass, what we often call a child class, can provide its very own unique version of a method that it gets from its parent. This is how we start creating more specific, specialized code. To really see this in action, let's build a quick example. We'll start with a really simple parent class. We'll call it animal, and it's going to have a default sound method. Okay, here's the code. Our animal class has one method, sound, and all it does is print out this super generic message. This is our baseline, right? This is the default behavior that any child of animal is going to inherit.
But let's be real, a dog doesn't just make a sound. That's not very useful. So let's create a dog class that extends animal, and we're going to give it its own, much more specific version of that sound method.
And here it is. The dog class overrides the sound method. It keeps the exact same name, the same parameters, but the code inside is totally different. Now, see that @override annotation? That's not just a comment. It's a really important signal to the compiler, telling it, hey, I am intentionally changing the parent's behavior here. Okay, so this brings us to the most important question. If we create a dog object and we call it sound method, which one actually runs? The generic one from animal or the specific one we just wrote in dog? And the answer is the child's method takes priority. It wins every time. This decision is made when the program is actually running at runtime, and it's based on the object's actual type. So even if your variable is of type animal, if the object it's holding is a dog, the dog's bark method is the one that gets called. This is a sneak peek into a huge concept called polymorphism. And looking at it side by side makes it crystal clear. Without overriding, we'd be stuck with animal makes a sound. But with overriding, our dog object now correctly barks. We've successfully customized the behavior for our dog class without having to change a single line of code in the original animal class. Now, this is a really powerful feature, but it's not the Wild West. Java has a set of strict rules you have to follow. Think of them like guardrails on a highway. They keep you from causing some really weird and unexpected problems. You've got to get these 4 rules right. Let's walk through them. First, the signature, that's the method name and the parameters, has to be a perfect match. Second, the return type has to be the same. Third, you can't make the access level more restrictive. So if the parent's method is public, you can't override it and make it private. And finally, you can't just start throwing new types of checked exceptions. These rules make sure you're always honoring the contract set by the parent class. We saw this earlier, but let's really focus on it. The @override annotation is your best friend, seriously. While it's technically optional, you should just always use it. It's you telling the compiler, hey, I fully intend to override a method from the parent. If you mess up, a typo in the name, wrong parameters, the compiler will catch it immediately and give you an error, saving you from a headache later on. And here's exactly why that annotation is so critical. Let's look at one of the most common mistakes new Java developers make. It's so easy to do. Look closely, see it? A capital S in sound. To us, it's a tiny typo. But to Java, sound with a lowercase s and sound with a capital S are 2 completely different methods. If you forget the @override annotation, this code compiles without any errors, but you haven't actually overridden anything. You've just created a brand new, separate method, and the old generic sound method is still there, just waiting to run when you least expect it. Okay, so we've got a handle on regular instance methods. But what about static methods? This is a special case, and it's a spot that trips up a lot of people. So let's just cut to the chase. Can you override a static method in Java? The answer is a simple, straightforward, and absolute no. You cannot override static methods, period. So what happens if you try? If you create a static method in a child class with the same signature as one in the parent, you're not overwriting. You're doing something else called method hiding. The easiest way to think about it is this. With true overriding, the decision on which method to run is made at runtime based on the object. With method hiding, the decision is made at compile time based on the variable's type. It is a super subtle but really important difference. Speaking of concepts that sound similar but are totally different, let's clear up another big point of confusion: overriding versus overloading. This table lays it all out. Overriding happens between a parent and a child class. Overloading happens all within a single class. For overriding, the method signature has to be identical. For overloading, it has to be different. But the biggest takeaway is this: overriding is all about changing an existing behavior, while overloading is about adding new ways to call a method with the same name. But what if you don't want to completely throw away the parent's logic? Sometimes you just want to add to it, enhance it, not completely replace it. This is where the super keyword becomes your best friend. In this example, the horse's printYourself method first calls super.printYourself. That explicitly tells Java, hey, go run the parent animal's version of this method first. After that's done, the code comes back and runs the new horse-specific stuff. It's the best of both worlds. You reuse the parent's code, and then you add your own special touch. So let's just wrap this all up. Method overriding is the key that allows a child class to provide its own version of an inherited method. It's the mechanism that unlocks dynamic, flexible, and really powerful behavior in our programs. So now we know the how and the what of overriding, but the next big question is, how does Java actually leverage this at runtime to make our code truly powerful? That's where the real magic happens, and it's exactly what we'll explore in our next explainer.